Okay. So the first part is easy. You already know about mean, median, and mode, right? So the mean is the average. We're going to use that in standard deviation, which we'll get to in a little bit in the packet. Logan, can we see your face? Maybe she can't hear me. Jacob says the SAT monsters get her. But well, maybe they got her. And then, so what are the mean ages of 6, 7, and 11? You just add those up. Whoa, my thing is like black. I don't know why.
You want to tell her she could try to leave and then rejoin her?
Yeah, you want it, Logan, maybe try to leave and then rejoin. Okay. Restart it, maybe leave and then rejoin is Jim's
Or
advice.
maybe someone else could explain. I think you could toggle your video somehow. I don't know. But
Yeah. So maybe leave and come back. Okay, so
yeah,
okay, we'll wait for her to see if she can come back.
so it's just your garden variety average formula, right?
Right. You add everything up and divide by how many things you have. So the median is the middle value. So if you have an odd set, it's going to be right in the middle. If you have an even set, it's going to be the average of the two. And we're going to use this with box and whisker plots. Which we'll get to in a little bit. So the median of these terms, all we have to do is average 12 and 13, and we'll get 12.5. Not so bad. Okay, the next one, the mode is the most common one. So the mode of these terms is going to be the one that's repeated, the 58. Okay, I want to do some book problems. So let's start with okay. Page 358, number 12. We're going to miss you guys. There's Logan. Maybe we could see her. Logan, can you see us? Three 58. And we're doing, what did I say?
Can't be,
Number 17.
can't be that.
Wait a minute. Number 12.
Number two.
Oh, number 2.
It's number two.
Oh, sorry. I hope, Logan, you can hear us.
Yeah, you could, as long as you can hear us, it's okay. We understand if there's a glitch with
Yeah,
Zoom today.
yeah. 358, number 2. So look at this. You have a data set X of 3. Wait, let's read the numbers after me, Jim. 5.
Yeah, 5, 9, 9, 13. And then the next one is 5, 9, 9, 13, 27.
So if you fly like an eagle above the problem,
Wait, just ask this question. Do we have to calculate the means to answer this question?
no, because look, this 27 is gonna, it means Y is gonna have to be bigger, right? So if you fly like an eagle, you can save yourself all that time. And so the answer would be B. And that's just a way of saving you time on the test. If
I know that might take like 3 minutes.
yeah, that's an easy one. You want to save time at the beginning of the test so that you have time for the harder ones. Okay, and then we're going to do 317 or no, sorry, 375. Number 17. Okay, so I'll let you read through it first. And if you want, make an attempt at it. So the range is the highest number minus the lowest. And so here, if we add 56 and move it all up, obviously the median is going to change. But do you see the range will be equal for both sets? So this one will be C. Hopefully that makes sense. And one more, 840, number 11. So I'll let you put these all on your calculator, add up and divide by how many numbers you have and see what you get. Logan, can you hear us? We don't even know if she can hear us.
She could tell us in the chat if she can.
Okay, just tell us in the chat if you can hear us, honey. I don't even know where the chat is on this.
It might just pop up if she.
Oh,
Oh wait, here, maybe this is it. Anything here? No,
no.
I don't know.
Okay, so did
Oh
everybody?
yeah, she put a little thumbs up that she could hear us.
Oh, good, Logan. That's good. Thank you. So it's going to be 90 divided by 10. Everybody get 9 for this one. And those are a little bit harder when you don't have a number to bounce it off with. Then one more easy one. The harder ones are going to be coming with, it's not so bad though. 962, number 1. Higher difficulty, but
First question.
first question, yeah. And you want to get to the higher difficulty ones. So there's 4 numbers down here, 4 numbers down here. And so everybody gets 79 for the median. Good. Okay, let's go on to the next page of the packet. Okay, so here we did the mode. An outlier is a data point that's well outside the rest of the data, and it affects the mean much more than the median. So when a distribution is symmetrical, the mean and the median are approximately the same. So here you could see this is the bell-shaped curve that they use for intelligence and, people's height. Even SAT scores get curved this way. So if you have the mean and the median should be approximately the same here. Okay, so let's go on to this page. Number 1. You can see this packet isn't as thick as everything else was. A certain stores, I'll let you just do this one. So you have, I would put them in order, because if you try to keep it in your brain, it only takes a second. 2022. So obviously the median, and what people mess up is they get the mean instead of the median. And then the mode is 30, so the difference between them is 5. So that's good, right? Take your College Board for 10 points. Okay. So let's look at number 2. What is the average? So if we had to average these 4 numbers, it'd be x plus 1. We could pick a number. And we have 4 numbers. So that's going to equal 4x plus 6 over 4. And I can't just divide by 4. I have to make that equal to 4x over 4. And then we would have 6 over 4, which is 1.5. And so this answer will be answer choice A. Make sense? Yeah, good. So this one, it make you realize how much airplanes cost. An audit was conducted of the price paid by an airline for a number of commercial planes. Those conducting the audit discovered that the mean average price was $350 million. The median cost was $275. So sort of sketch it out. Can you see? I'm going to draw some airplanes here. These are my little bad airplanes. Okay. So if the mean is greater than the median, that means that there's some more planes over on this side, right? To make the mean, to affect the mean. So the answer for this one is C. There are several planes that cost more than the others. We don't know how much the planes cost. There definitely are not several planes that cost less than the others. We don't know if the planes cost close to one another. So that one is C. Okay, moving on. So we have a bar graph here. Okay, so the bar graph above depicts the number of puppies per litter for a number of dogs that recently gave birth. What is the average number of puppies? So we have one mother who had 10 puppies, plus we had 2 mothers that had 2 puppies, plus 3 mothers had 4, sorry, it's hard to write on the screen. 4 mothers had 7, 5 mothers had 3, 6 mothers had 6, and 7 mothers had 5. And we know how many litters we have is 1 plus 2. We count up all the mothers. So that'll be 10, 11. How many litters are there, Jim? 28?
28. Just 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1.
Okay, so there's 28 litters divided by 140 puppies. So that's an average of, is it 5 or 4?
5. Dominic's here.
Oh, Dominic. Yay. So let me just retrace our steps here for Dominic. So we're doing this data and statistics packet. And also, I just want to,
Oh,
yeah.
let me bring it up.
So for you, Dominic, these are the things you're going to need for Saturday. Plus, everybody know I'm going to be praying. I get up and I pray. So you should feel angel wings around you. So just scan this, Dominic, so you know all these things you have to bring on Saturday. we'll let you look at that. Write anything down you need to. Okay, so now we're on page 5. This one's a hard one, number 2. The table above shows the attendance at the home games for a football team. If the median attendance is 345. So that means there's 5 numbers. The middle number is 345, and we want median, not mean. And no games had the same attendance. What is the greatest possible value for n? So we know if this is 345, then we're going to have a 422 here. This is 345. We have a 485 here. We're just fitting everything in. And down here we have a 302. So it says that no games had the same attendance. So we can't have a 345 here, and we can't have a fraction, or we'll have a murder right on the SAT. So this has to be 344. How many see that it has to be 344? Julia sees it. Sailor, you're good. Dominic, good. Okay, and there'll be about 5 questions on your test from this. Okay, so the next thing is histograms. They put histograms on the test. So his strategies are pretty sophisticated. He found, so if we have to get the average score, the book tells us that we have to get the lowest score here and then the highest score. And then it's a lot of work. So Jim's method is to get the average of every one. So there's 3, because you don't know where these points are. Do you see what I'm saying? In a histogram, you can't get those specific points. But we could say there are 3 points that are at 67.5. I just averaged these 2 numbers, excuse me, and to sneeze. Plus, there are going to be 4 numbers. Everybody starts to see the plan here that are about 72.5. Plus 6 numbers that are 78.5. 77.5, sorry. Plus 4 numbers that are 82.5. Plus, let's see, 92.5
You're
is,
skipping 87.5. You have 8 at 87.5.
so 8 at 87.5 plus 9 at
7 at 92.5.
sorry, 7 at 92.5. And finally, 2 at 97.5, right?
Yeah.
So you calculate all that up, and they tell you 34 exam scores.
So we're dividing everything by 34. Right?
Yeah, and so we get a big number divided by 34. And the answer is about 83%. Does that make sense? To get the average instead of doing every low number and every high number. Good. So I want you to try a book one. It's really hard. So we're going to go to page 847. It's the highest in the higher difficulty, number 21. So I'll give you a minute to go there.
Let them try. Let them try to do it.
Yeah, I will. Okay, give it a try, guys.
This is good practice for Saturday.
Yeah. This is the next to the hardest question on a test.
That's, A is low, B is high,
Oh, really?
because 20 is the lowest A could be.
Yeah, but we want to get the smallest possible difference.
Yeah,
So we
that's why
want,
we're making A,
we
we
want,
want the 20 from A. You see how there's a 20 in A?
yeah, we
Yeah,
want,
we want that,
yeah,
but,
don't
oh,
we?
yeah, we want it low. Yeah, we want A low,
I don't see why, because
because you also want
we want the
9 is
smallest,
50. 50 is the lowest this bar could be.
right?
So we want A low, B high.
But that'll make a big difference. We want the smallest possible difference.
Yeah, but if we make this as low as possible, we get a 20. If we make this as high as possible, we get a 19.
Yeah,
That's what I mean by high. Like B is the highest that bar can be
yeah,
at 19.
yeah,
So low, high. They can't both be low. Low, high.
but we want to get the smallest difference between A and B.
Right. So what I'm saying is if we make this as low as it can be, which is 20, we make this as high as it can be, it'll be 19. So there's only a difference of 1 between those bars.
Okay.
I don't know. That's how I think about it. Or no, maybe you're right.
Yes, I'm right.
Okay, sorry.
Oh, thank God.
Nine and 50 is the last one for that.
Okay.
And then we're dividing by 23. That
Yeah.
this is all over 23. And then no plus sign because that was the last term.
Yeah.
Okay, now we can do the B's. So sorry for messing you up there.
No, okay, so it's 3 at 19 plus 4 at what? Just read them off to me. 4 at
4 at 29,
mm-hmm.
7 at 39, 9 at 49. Now that's over 23 as well. So if you make the first one into a fraction, it will be 9/10 over 23. Well, don't put that, they're gonna think it's the bottom.
Okay, I know.
You can put it over here or something. Yeah. Okay, and B will be 887 over 23. And that equals 23 over 23.
Did anybody get one? No?
You're gonna have to explain this.
Okay, so
Just read the whole problem because you didn't read it yet. I think that's
okay,
probably the problem.
okay, hold on. Sorry. Two data sets of 23 integers each are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of intervals greater than or equal to 10, but less than 20. The second interval segments represents the frequency of intervals greater than or equal to 20, but less than 30, and so on. What's the smallest possible difference between the mean? So that means we have to calculate the average. Now, this is the next to the hardest problem on the whole test of data set A and the mean of data set B. So does that make sense? So we want to make A the highest it can be. So the highest A could be,
I thought you said we're making A low. Or no. Now I'm doing it again.
yeah, we want to make A high and B low so that the difference is small. So the highest A can be is a 23 at 20, 4 at 30, 7 at 40, 9 at 50. B, we're trying to make low. So the lowest B can be is 3 at 19.
I still think we're trying to make A low and B high. Why am I thinking that?
I don't know. Does anybody see it now? Julie, do you see
Yeah,
it?
we're making A low and B high.
No, we're not.
Yeah, we are, because the highest A could be would be 60, but we're doing 9 at 50.
Because we want to make,
A low and B high.
no,
Yeah.
because then the spread would be,
No, but look, right here. The highest we could make A would be 59,
right,
but we're making it we're making it 50
right.
because we're making A low. The highest we could make this one is 49, which is what we did. So B is high, A is low.
Okay,
Yeah.
I'll take this.
I mean, other than that, I think we agree on everything.
Yeah, but we're having a little mental conflict here. Okay. Sarah, does it sort of make sense to you now? Dominic, I'm looking for a thumbs up. You're sort of in the dark there. Thank you. Okay, now we're going to box and whisker plots. I still think. Okay, so this relates to they'll ask you about this. So this is
Let
going
me
to,
just ask you, have they seen this before?
okay, how many of you have seen box and whisker plots before? Julia has. Dominic, have you? Oh, good.
Oh, good.
So this is the median. These are the whiskers. Oh, Logan's back, sort of.
Yeah, Logan's here. It's fine.
Okay.
So that's always your median, right?
This is your median. This is the highest point, lowest point. If you remember, this is the third quartile, and this is the first quartile. So it says the box and whisker plot above depicts the number of doctorates earned each year in science and engineering from 2000 to 2009 in the US. If 130 doctorates, 1,000 doctorates were awarded, so we're going to go up to this point. What measures have changed? Do you see? They've all changed because the median will have increased, the mean will have increased, and the range will also have increased. Does that make sense that the answer is D? Okay, so now we're going to try a book problem. And we're going to go to page 600, number 14. I still want to talk to you about this.
That's fine. I I I think we agree on it.
Better bring out the swords. So if you look at this, we're in number 14. The two box plots show the distribution of number of books read over the summer by the students in two different English classes. What is the positive difference between the ranges of numbers of books read over the summer for the two classes? So the range will be the highest number minus the smallest number. For class A, that's going to be 0
That's the lowest.
to 5.
5 minus 0, right?
So the range for A is 5. That makes sense, right? The range for B will be 10 minus 1, which is 9. And now we want the positive difference between them, which would be 4. Does that make sense, Sailor? Julia, good. Dominic, good. Oh, good. You were so in the dark, Dominic, but I can see your thumb. Okay. So let's go on to the next page in the packet. Like I said, this isn't too bad, but there's going to be stuff on the test from this. Okay. So students kept records of the heights of plants growing in their classroom, as shown in the histogram above. What is the range in height? Now, the tricky thing about this is usually you expect height to be on the y-axis, but here it's on the x, and so the difference in the height will be 5 minus 1 or 4. That makes sense, right? Good. Okay, now this next one, you probably have done this. Have you ever gotten your grade in a class and then found out what you need to get on the final to get a certain grade for the semester? Maybe you've done that. So we're going to use the same old average formula, which is the sum over the number. So we did it on the next page. You'll see the mean was 91. There's 7 values. So we put them all up here. I just want you to do this a couple times here so you have the mental memory to do it on Saturday. We're trying to find this last grade we need. So we multiply 7 times 91, which is 637. We take away all these added together are 546. So the student has to get a 91 to get an average of 91 on the test. That makes sense? So let's go to,
Could you tell them that announcement about what, the weather and,
oh, so Jim's concerned about the weather here because we had tornado warnings earlier today. Now it doesn't look like a
no, I
problem.
still want to mention.
If we lose you, just come back in 5 minutes.
Yeah, it probably means our power went out or something. It
Or-
has happened before.
Or if it
That's all
goes
I'm
out,
trying to
but
say.
I'm praying and everything's gonna be good.
Yeah, but we'll always be back in like
Yeah,
5 minutes.
we'll always be back, so. Okay, so let's try a book problem. So I wanted to try 221, number 3. I want you to try this one. All you have to do is get the setup right. So he wants to get 90 or greater. We don't even have to solve it. We just have to see the right setup. How many had C for the right setup? Do you see it? Good. Okay, great. Okay, we're gonna keep going. Like I said, this packet isn't too thick. We covered all the tricky things before. So we're finding temperatures in March. So again, I'm just doing this so if you get one like this, you'll have the mental memory, because you maybe haven't done this in a while. So we're trying to find, so we know we're using a garden variety. Mean is the sum over the number. Here we have 5. And the mean temperature is 42. We want to see what it's going to be in March. So we'll have 26 plus 36 plus we don't know plus 46 plus 54. Whoops. The SAT masters got Jacob real bad.
Yeah, maybe they did. I'm just thinking how apropos that you're doing a question about the temperature in March.
I know. Did anybody get 48? Yay! Okay, Dominic's good. Okay, a couple more like this, and then we'll go into the standard deviation stuff. Oh, and Logan's still here.
Yeah.
Thank Logan, we didn't forget you. If the average, I mean, this is where you really need to push at the very end here. I'm going to pick a number for this one. That's one of the things in our strategy box. So I'm going to call A2. So the average of 2 and 4, two numbers, is 6 over 2. So 3 equals X. And then I'm going to get the average of 2 plus 2 minus 0 over 2. So this is where picking numbers just helps a little bit. 2 over 2 is 1, so y is 1. Then we have to get the average of x and y. So x plus y over two numbers, that's going to be 2 over 2, which will be, 3 plus
4
1.
over 2, right?
4 over 2, sorry.
Yeah.
Which is 2. And so the answer for me was A. Does that make sense?
And you could do the algebra if you prefer
Yeah,
algebra.
it's just it gets confusing because I don't know. I like that picking numbers to bring it down to the logical things. Okay, so let's try 3. Okay, we have 6 rocks and the average is 12. So that means the sum is 72. We're going to add another rock, so that'll be 7 rocks. And that's going to go up to 11.
15, right? Where'd you get 11?
Oh, I'm sorry, I'm reading this problem.
Oh.
So that's going to be 105 for the sum. So then all I have, that's sum, not sum. So then all I'm going to do is take 105 minus 72. And that last big rock had to be 33.
Maybe we'll keep this up for a second because someone had a question about this one on Sunday. But is
Yeah.
everyone cool with this one?
Are you cool with this one? Give me a thumbs up. Yes, Dominic went black. Oh,
I know we saw
so
him.
his head popped up. Oh, he's really in the dark. I hope you're okay there, Dominic. I can't see much of you. Yeah.
Alright, so that was that one.
Okay, let's
Or you
do.
got a book one like that, or
No, I didn't.
Oh.
So let's try one more and then we're going to be done with this. So if we average, we're using our old average formula. We're not changing because they won't give you this on the test.
On the formula page.
No, it's not going to be on the formula page. So 8 is the average. We have 3 numbers. So the sum will be 24. Then when we have the average of A plus B plus C plus D is 11. That's 4 numbers, and that sum is 44. So 44 minus 24 will be 20. Thank you, College Board, for 10 points. Okay, does that make sense? And by the way, I'm going to forget this, so just remember we would love to know your score when, if you could email me your score, you might not want to, but, and you still have, it's not like in China, you have May, June, and you can even take the test in August. So you have other opportunities if, I'm going to pray on Saturday that you hit it out of the park. Okay. But, and also if you let us know your score, and if you tell anybody about this course, if it's helped you, then, and they sign up, we give you $50 towards your college education. Okay. So we have trouble getting the word out about our class sometimes. I don't even know how Sailor found its way out in Trinity, but we're glad she did. Okay. So now measures of variation. So we've already talked about the range being the largest minus the smallest. Okay, this is the thing you may not have heard about. Standard, I think you did it in 6th grade on the keystones. So standard deviation, when you have data set, it's the difference that is from the
Deviation from the mean.
mean. The box and whisker plots was the median, but this is the mean. You don't have to know the formula.
You just have to know what it is.
You just have to know what it is. So I got a book on statistics for dummies, didn't help at all. And then I got to thinking, when boxers, you have a septum in your nose, it's cartilage. And if you've been beaten up in boxing, you have a deviated septum. That's how I thought about this. So here, the next picture will show what I mean. So the lower standard deviation, and this is a little crazy because it's Mrs. Hessler, if it looks like a nose. I know it's a little stupid, but
If it looks like a nose, what?
if it looks like a nose, somebody you would want to go on a date with, it's a lower standard deviation. If it's a high standard deviation, you see the difference?
So the data is more spread out.
Yeah, the data is more spread out. So my nose thing, let's actually try some. So the first thing I want to go to is, let's see. Now there's one early on in the 200s. Do you have that one?
Yeah, but I could probably find it.
Yeah. Jim's looking for it. It's going to be in data and statistics.
Okay, I'll find it.
Just a second, guys. We're looking on it. I think I found it. Okay, so it's going to be on, one second, page 267. And we're going to look at the example. Okay, so I'm just going to sketch it out here. So A has dot, 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 dot. B has this. So if we were to draw a nose, that would be that nose. This would be this nose. Which looks more like a nose? Probably set A, right? I mean, I know it's a stupid thing, but so the standard deviation of quiz scores in class A is less than class B because they're really spread out. Does that
They're closer to the mean.
Yeah, they're closer to the mean. Does that make sense? Okay, good. So we'll do a couple, well, let's also go to 480. Let's see what this one is. 486, number 10. So this is easy if you know what it is. No, it can't be down that page.
That's a range one. Just do it.
Okay,
It's a range.
it's a range one, but it's easy. So what's the range of the seven scores? It would just be 52, the highest score, minus 23, which would be 29. Right? Not so bad. Okay. Now the next thing we're gonna go over,
Well, where are those other standard deviation ones?
Oh,
We should probably do that.
yeah. What about 375? Hold on. Yeah, we're having some stormy things here, but
I think you did this one.
I don't know.
Yeah, you did this one.
Did I do 15 though too?
No, but 15 doesn't look. Not 15 from this module doesn't look like it's the
Oh.
things.
Okay.
There are some some that we want to do.
Yeah, you find them.
I don't know where they are.
Yeah.
Um,
Okay, so let's go to,
did you do? Hold on. Did you do 267 number 12?
I don't know, I think I did. We're checking here, guys. We like to do.
Oh yeah, you did do that one.
Yeah. He's looking, but let's go back to the packet while he's looking. So here, let's look at number 1 back in the packet. So the histogram above summarizes the ages and months of children in a daycare. We're going to put another kid right here in the daycare. What effect does that have on the median?
Well, what was the median already?
The median already was right here. So we're going to just tell you that the median is right here in this block.
There's 7 to the left of that bar, 7 to the right of that bar.
Yeah, 7 to the left, 7 to the right. And then if we add the standard deviation or one more kid,
Well,
do you see that? We got a phone call. Is it important? No.
so important.
Okay, so that's going to make it more like a nose. And so the answer for this one would be the standard deviation would decrease, right? Jim, it's B.
Yeah.
Okay. And yeah, we have some stormy things going on here, but anyway. Okay, let's look at number 2. Lord, keep the power on. Okay, of the following sets of numbers, which set has the smaller standard deviation? So do you see it would be D? Because the numbers are closer. Okay, and this one, what person would you want to go on a date with? Not that nose, right? That would be bad nose. This one's going to be a weird nose. This one would be a really weird nose. Although this one isn't the best, it's better than all 3. Does that make sense? The standard deviation is the lowest right here at B.
I found you a problem.
Okay, what page?
It's 1077.
Okay, Jim found one. Can I do it?
Yeah, I hope so. 1077, number 8.
Okay. I think it bodes well that you guys are here to the very end. 1077, number 8. Okay. Higher difficulty, ding, ding, ding. The dot plots represent the distribution of values in data sets A and B. Which of the following must be true? not could be true, but must be true. The median of data set A is equal to the median of data set B. Does everybody see?
That's just the middle number, right?
Right. One is good, right?
So the medians are both 13.
Right. The median is 13. The next one says the standard deviation of data set A is equal to, not really, because do you see the standard deviation here has 1 point and 1 point, but the standard deviation of set B is 2 points and 2 points.
The curves are different.
The curves are different. Does everybody see that? So these are not the same standard deviation. So the answer has to be A1 only. Does that make sense, Julia? And Dominic, good.
I got the next one.
Okay.
A33, number 5.
Thanks, Jim.
Yeah.
Okay, take a stab at this one. Each of the dot plots shown represents the number of glue sticks brought in by each student for 2 classes, Class A and Class B. Which statement best compares the standard deviation of the number of glue sticks brought in by each student? So I'll let you read through them all and lock in an answer. Did anybody pick B? The standard deviations are the same? Oh, yay. Okay, I'm going to be praying for you on Saturday. That's great. Thanks, Jim.
Yeah.
Okay, so we're going to keep going here. Okay, we're now on. We do. Yeah, that was good. Okay, let's back to the packet. We just have a little more. Those are all our nose messes. So the Kentucky Derby comes in May. The dot plot above depicts the height in inches of jockeys who participated in the Kentucky Derby. What would happen to the standard deviation of the data set? So if we take off the lowest jockey and the highest jockey, do you see the standard deviation? It would go smaller. So the standard deviation would decrease. Does that make sense? Good, you guys are becoming statisticians. And there's a major in colleges, it's called actuarial science. You become an actuary. So if you like math, I'm just mentioning this. My brother's friend became this, and he went all the way up to president of an insurance company. So you said they get paid well.
Yeah, they make more than accountants do.
They make more than accountants. Wow. So,
Yeah, a junior actuary, I think, starts at 100K.
oh wow. So a junior actuary starts at 100K. So if you like math, just a plug, this could be your ticket. Or maybe Sailor wants to be a math teacher. I don't know. And handle students. Okay, let's go to the next thing, last thing started to cover. So we're not going to worry much about population parameter. So margin of error, we are going to worry about. So like in a presidential election, they can't go out and interview everybody that's there in the country, right? So that means they take a sample and then they extrapolate who's going to win. So would it be easier to hit a small dartboard or a large dartboard? It's going to be easier to hit the large dartboard, right?
Give you space to write it.
Yeah.
Down.
So what I want to write, this is my large dartboard and my smaller one, here's my dart. So the larger, this means the larger the sample size, the smaller the margin of error. So take a minute to digest that. So the more, does that make sense though? Okay, and we're not going to worry so much about confidence interval. So let's go to the next page. We have an example problem. And like I said, we're almost done with math. But I'm going to miss you guys. Anyway, in a particular study, a sample of the population, I'm on page 13, shows that 92% of the households in a county lived in the same residence as they had the previous year. The estimate had a margin of error of 1.5. Don't worry about the confidence interval. If the county has 6,000 households, what's the number of households that lived in the same residence? So it's 92%, but we're going to do plus or minus 1.5. That's the important thing to think about. So that means minus 1.5 would be 90, and then up to this much. So then we're going to take between this number and this number, and so the answer has to be C. So you're sort of getting a crash course in statistics, right? But that sort of makes sense. So let's go to a book problem. Let's see. Hold on. I got it. 492, number 3. See if we've done that one. We have.
No.
Okay, let's go there. Okay. So it says a company that produces, what is that, socks?
Yeah, socks.
Socks, whoa. They want to estimate the percent of the socks produced in a typical week that are defective. So they take 310 socks out in a certain week. It's estimated that 12% of all the socks are defective with an associated margin of error of plus or minus 3.62%. So that means we have, whoops, I messed this up. So we're taking 12%, right?
Yeah.
So that means it could go up to 15.62, or it could go down to 8.38. And plausible, they love that word. So the answer is B. Does that make sense? So if you get one, you sort of know how it sounds. Sounds right, right? Wonderful, wonderful, wonderful. Okay, and back to the packet. We're almost done. So we're going to the crew team. Researchers measured the heart rate of crew members during a 2,000-meter race. The researchers found that the mean heart rate was 146 with a plus or minus error of 14 beats per minute. So that means it could be up to 160 or down to 132. And so the answer would probably be 140. It makes sense? Okay. The next page before an election, 1,000 randomly selected voters in California were surveyed about what single issue was of their most concern. So 670 voters said the economy was of most concern. Which statement about all voters in California is most appropriate? Could we ever say exactly with statistics? No, good job. Could we say approximately? This would be close answer, but the best answer would be D. Then one more, and we have 3 in the book. I have 3 in the book, Jim. So, a baseball enthusiast randomly interviewed 45 major baseball league players. He said, "How many bats do you typically use in a season?" The average number of bats used was 90, and the margin of error was 5 bats. Another baseball enthusiast intends to duplicate the survey. He wants to get a smaller margin of error. So he needs more baseball players, right? To get a smaller margin of error. So our answer would be C. It would be 200 randomly players because we have to still stay with the major league. So a couple of book ones.
Could you do the one on 269?
Yeah, I have it right here. It's right here. 269, number 13.
Yeah.
So we're going to try 269, number 13. Almost done with math. And the storm hasn't kicked us off, so that's good. So on 269, we're just going to read this together. A quality control researcher at an electronics company is testing the life of the company's batteries in a certain camera. The researcher selects 100 batteries at random and finds that the life of the battery has a mean of 342. So you don't have to have that much statistics, with an associated margin of error of 18. So if we add 18 and subtract 18, we'll have 360 and, oh wait, sorry, this way. Up to 360 and bigger than 324. So read the answer choices.
What is your inequality?
Is that crazy?
Yeah, that's crazy.
So plausible means reasonable. A and B are out because we can never say all. With statistics, you can never say all and you never can say exactly.
It's always an approximation.
Yeah, it's always going to be an
They
approximation.
would have to test every single battery that the factory
Yeah.
made, or
And you see, D is crazy because it says the mean life of all the batteries ever produced by the company. But C is our most reasonable answer. How many see that? It's C.
Could you also do?
Yeah, the next page.
Yeah.
271.
Yeah.
So let's go to 271. We're trying to give you best SAT class you could ever have. Number 14.
These are just like some last minute things you might see. We want
Yeah.
to make sure you
Yeah.
did them.
So a community center offers a Spanish course. This year, all students in the course were offered additional audio lessons they could take at home. The students who took these additional audio lessons did better in the course than those who didn't. Based on these results, which of the following is the most appropriate conclusion? Now, the right answer is D because, just tell me that cryptic thing you have.
Correlation
Correlation.
does not mean causation
Correlation
necessarily.
doesn't
There could be a third factor that is affecting both of these
doesn't
things.
mean causation.
Yeah.
And then the last one is 275.
It's hard to prove causation, actually.
Yeah. So let's go to 275, number 7. We pretty much Okay. A sample of 40 fourth grade students were selected at random from a certain school. The 40 students completed a survey about the morning announcements. 32 thought the announcements were helpful. Which of the following is the largest population to which the results of the survey can be applied? Well, A, we already have. We already have those 40 students, so we're not doing anything to it. The answer is B. We could go up to all fourth grade students at that
But
school.
you cannot, yeah, you cannot extrapolate beyond the type of students that we polled, which
Right.
were fourth grade students.
Right. So we can't do all students at the school. We can't do all fourth grade students in the county. Does everybody sort of see that? I'm just trying to get a feel for this. Okay, so our last thing, does everybody have an extra page added onto your
Oh,
packet?
what about this one that's like right where you just were?
I think it's in
Number 5.
I think it's yeah, it's in this packet.
Oh, okay.
So does everybody have an extra page added to your packet? Sailor, you have an extra page. See, that's the same.
Oh, that's the okay.
Okay, so I want you to try, and I'll give you about 5 minutes. Take your time. You're going to do the two problems on one page and then the two problems on the back. So they are numbers, what are they? 28. 28.
No, we got. I think it's 25. My copy's hard to read.
Yeah,
I
mine
think
is,
it's 25, 27, 37, 38.
and then two problems on the back. So take 10 minutes and this will conclude my wonderful math time with you, which was which is a blessing. What was it, 37, 38?
Yeah, I think so.
So take your time. They're almost done.
Yeah.
Wait, one second. This is very petty.
Oh,
Yeah, when the hairdresser does it. You know,
yeah, I don't know.
check one.
Check one.
Okay. Okay, let's go over these. So the first one, a data set. Hold on. A data set of 27 different numbers. It has a mean of 33 and a median of 33. So that means it's a bell-shaped curve, right? So a new data set is created. We're going to add 7 to every number.
Greater than the middle.
Greater than the median, and subtract 7 from a number in the initial data set.
Less than the median.
Less than the median. So the median won't change. The mean will stay the same. The sum of the numbers will actually stay the same because they'll cancel each other out. So did anybody have D for that one? Oh, good. And that was a hard one. It was a 25. So let's look at the next one. So sample percent. So we have A and B. A is 52%,
Plus or minus 4.2.
plus or minus a margin of error of 4.2. B is 48%, margin of error plus or minus 1.6. So the results of 2 random samples of votes for a proposition are shown above. The samples were selected from the same population, and the margins of error were calculated using the same method. Which of the following is the most appropriate reason that the margin for sample A was bigger? So if the margin is bigger, that means it's a smaller dartboard, right? And so the answer again was D. How many had D for that one? Oh, good. See, you could become an actuary science person. Next page. Okay. But the world needs math teachers too, so I don't know. Okay, so on this one, 37, right? Is that what it
Yeah, I
says?
think it's 37 and 38.
Okay, 37. So if we look at the frequency here,
You want me to read them or?
yeah,
You have one that is 2, one that is 3, 2 that are 4, one that is 5, 3 that are 6. Am I reading these too fast?
yes, start
I'm
over.
sorry. I'll start over. You have one that is 2, one that is 3, 2 that are 4, 7 that are 5. Remember, that might be a 1. Yeah, 1 that are 5. Sorry, it's hard to read this.
I know.
3 that are 6, 1 that are 9. And then that's all of A.
Right, it adds up to be
Are we trying to do the mean? What are we doing?
the median.
Oh, the median.
So the median for A was
Oh,
6.
yeah, I got a median of 6.
And then B,
Okay, we have 4 that are 5, 2 that are 6, 2 that are 8, 1 that is 9, 2 that are 10.
so the median of set B is 5, right?
Right.
So 6 minus 5, did anybody get 1? Oh, wow, everybody, woo, woo. I'm still praying on Saturday though. And the last one. Okay. So before I start this, I read a New York Times article years ago, and they said this girl wrote her story, and she said she went to her SAT, and she sat down, and she started taking her test, and then the girl behind her just started to sob through the whole test. So if anybody does that on test day with you, send them to us, okay?
Oh, what about like what not to
Boys,
do? Night before.
oh, the night before, just relax, watch a movie. Don't break up with your significant other. I had a kid that went to all night bowling, no kidding. And I thought, well, how did you think that was going to help? All night bowling, and then he went to the SAT. So we've had crazy things. Okay, number 38. For a certain computer game, individuals received an individual score that ranged from 2 through 10. The table below shows the frequency distribution of the 9 players. So for A, if you look at the bottom, it says we're doing the mean here.
Right, and A has 9 players, B has 11 players.
So we're going to use our average formula where we have 9 players and the mean score is 5. So that means the sum is 45. And then for B, we have
11
11
players.
players. The mean is 7. So that means the sum is 77. So we had 45 and 77. 122 divided by 20 players. Did anybody get 6.1 for this hard one? Oh, wow, all 3 of them.
Woohoo.
Okay, guys, I'm praying on Saturday. Let me know your score. I'm gonna,
Can you write down and take a break?
yeah, break until what?
Um, let's say like I want to give him like a good 10-minute break. It's 6:53.
Yeah, 7:03.
7:05.
Okay, get something to eat, use the restroom. Good luck, good luck. I'm praying for you on Saturday. You'll feel angel wings. I know you will. Okay.
All right, let me know if you're back. Oh, everyone's back. Hi, Julia. Hey, Sailor. We're gonna do some English review today. So we finished all of the English packets. So we're just gonna do review. All right. Dominic's back. Logan, I'm assuming, is back. All right. Okay, so we're gonna do some review. I'm gonna give you the page number. I'm just waiting for this to come up on the screen. Okay, this is page 934. 934. So find this one. Okay. So we are in the harder module. We're in the higher difficulty module 2. And the students on Sunday actually thought these were pretty hard, but I don't know. I didn't want to do easy ones. So we're just going to do, I want to do just the sentence completions first. So these blank, fill in the blank ones. So I want to do 1, 2, 3, and 4. We'll just do all the sentence completions first. And I think we'll just do these in batches. I don't want to give you like 20 questions in a row. We'll just do a small batch at a time. So let's try 1 through 4, and we'll treat it like the real SAT. Try to do them in about a minute or so. So we'll take about 5 minutes to do these 4. All right, so I'll just let you guys give these ones a shot. Okay, it's been about 5 minutes, so we'll go over these ones. Okay, so let's try this whale one. Within baleen whale species, some individuals develop an accessory spleen, a seemingly functionless formation of splenetic tissue outside the normal spleen. Given the formation's greater prevalence among whales known to make deeper dives, some researchers hypothesize that its role isn't blank. Rather, the accessory spleen may actively support diving mechanisms. Okay, and we have our words to choose from which to choose. We have replicable, predetermined, operative, and latent. Okay, so if something is replicable, it's repeatable. If something is predetermined, it was determined ahead of time. If something is operative, means operational or exerting some kind of force. And then we have latent, which means present but not active. Did anyone go with D latent for this one? Sailor did, Julia did, Dominic, you good with it? Okay. So kind of tricky because they're saying this is not. They're saying I'm just going to read it in the sentence. Let me just read latent right here. It says, given the formation's greater prevalence among whales known to make deeper dives, some researchers hypothesize that its role is not latent. Rather, the accessory spleen may actively support diving mechanisms. Okay, so I'm going to cross these wrong answers off. Okay, number two, read this one. All right, the province of, I think it's Hokanocho. I think that's how you would pronounce this. I'm not sure. I didn't take Spanish. The province of Hokanocho was situated on the Pacific coast, hundreds of kilometers southeast of Tenochtitlan, the capital of the Aztec Empire. Because Hokanocho's location within the empire was so blank, cacao and other trade goods produced there could reach the capital only after a long overland journey. So here is our answer choices here are unobtrusive, concealed, approximate, and peripheral. Okay. So if something is unobtrusive, it's not jutting out. Um, Concealed means hidden. Approximate means we can't determine its exact location. Peripheral means it's on the outside of something, the periphery. Okay. So I'm just going to see if I can eliminate some answer choices. Do we know that Hokanocho, do we know that Hokanocho's location within the empire was concealed, hidden? I don't think there's anything in the passage explaining that this is a hidden location. Is it unobtrusive? That doesn't really make any sense. Its location was so approximate. That doesn't really make much sense to me. Peripheral is the right answer. So if we are hundreds of kilometers from the capital, that would be on the periphery, and that would take a long journey to get there, basically. Okay. So they're getting kind of tricky. I'm only at number two, and they're already pretty hard. But we're in the harder module too. So hopefully we'll see how the next couple go. All right. In 2016, Gabriela Gonzalez and team announced that a chirping sound captured by laser interferometer gravitational wave observatory antennas was direct evidence of gravitational waves, which skeptics had argued would be too faint for detection. Detailed statistical analysis helped preclude claims of the event's blank, confirming the signal at a confidence level of over 99%. And our answer choices are inconspicuousness, discretion, ambiguity, or probability. So if someone is inconspicuous, they do not stand out. They fit into their environment. They do not draw attention to themselves, something like that. If you have discretion, you have discernment. If you're discreet, ambiguity. So if something is ambiguous, it's unclear. And probability, that's just a math term, right? So that just means the chance of something. Okay. So detailed statistical analysis helped preclude or exclude. We can use these interchangeably. Detailed statistical analysis helped exclude claims of the event's ambiguity. So we ruled out the idea that this is ambiguous. It is not. They confirmed it at over 99% confidence level. Okay, so kind of a tricky one. On to number 4. And here's a hard one. So it says political blogs with conspicuous ideological alignments became an integral component of US media in the early 2000s. While some commentators lauded this development, that means they like it, they applauded this development, asserting that such blogs had a welcome transparency missing from traditional news, less blank observers countered that such blogs tended to ideological extremes that exacerbated or made worse political polarization to problematic levels. Okay. And then here's why this one's tricky. Look at our words. We have sanguine, recalcitrant, misanthropic, and earnest. So I think that they were sort of lying about there only being tier 2 words on the test. I think that there are hard words. They come out they all live in module 2 higher difficulty. Because I wouldn't consider sanguine to be a tier 2 word. I would consider that to be tier 3, just personally. All right, so if you're recalcitrant, that means you're defiant of authority. Misanthropic. Does anyone know what this means? I don't know if we've encountered it yet in this course. Anthropology is the study of people, but the mis negates that. If you're misanthropic, you like to be alone. You don't like the company of other people. Well, that doesn't make any sense. I'm going to cross misanthropic off right now. And recalcitrant, less defiant of authority observers. That doesn't make any sense. I'm going to cross off both of those. So if you're earnest, you're serious. And then we have sanguine, that other hard one. Um, Less earnest observers countered that such blogs tended to ideological extremes. So what does sanguine mean? It means optimistic. Maybe you want to maybe write this down just in case this pops up on Saturday. It could. Um, so the way this word is derived, it actually means, let me write it out. Sanguine. It means of or pertaining to the blood. It's like an old word. Um, but what they're saying is optimistic people, they have cheery red faces. That's what this literally means. It means like a ruddy, red-faced optimism is someone who's sanguine. They're optimistic. Let me read optimistic in the sentence. This should make perfect sense because it's a synonym. While some commentators lauded this development, asserting that such blogs had a welcome transparency missing from traditional news, less optimistic observers, less sanguine observers countered that such blogs tended to ideological extremes. That was the right answer. What about this? I just thought of something else. What does it mean if you're consanguineous with someone else? Um, so this would be someone like a brother or a sister, not a husband or a wife. Yeah, I'm not really sure where you would have encountered this word sanguine, but maybe if you read the New York Times or the New Yorker, or you read old literature, you would have seen this word. It's, I don't know. I 100% think this is a tier three word that they just put on this test. But that's just me. I don't know. I don't write these questions. I just do them. All right. So I think we're gonna do another batch. I'm just gonna see how many I would like to do. Let's try and just keep track of any that you miss. Because we're gonna treat this like the real test. Let's try the next 2 pages. Let's do 5 through 8. We'll take another 5 minutes or so for the next four. So give these ones a try, and it looks like we have a poem for number 5. So read the poem and give these ones a shot, and we'll just go over these in about 5 minutes. Oh, Jacob's here. What's happening? Glad to have you along. We're just doing our English final review. Let me give you a page number. We're doing page 936 and 937. And just you could just follow along. We just did a couple of these, so we're gonna go over them. Okay. Did anyone need t more time for these four? Are we good? Okay, we're good. I'm not trying to rush us. Do you need more time? Anybody? No? Okay, good. All right. And then we got everyone on board. We'll post this later, Jacob, if you want to look at. We just did data and statistics, so you can watch that later. I'll post it tomorrow. It might be in the evening by the time it gets on YouTube, but you know the drill. That's where we keep all the videos. All right, so we'll do one of these. All right, so we got a poem. The following text is from Charlotte Fortin Grimke's 1888 poem At Newport. Oh, deep delight to watch the gladsome waves, exultant leap upon the rugged rocks, ever repulsed, yet ever rushing on, filled with a life that will not know defeat. To see the glorious hues of sky and sea, the distant snowy sails, glide spirit-like into an unknown world. To feel the sweet enchantment of the sea thrill all the soul, clearing the clouded brain, making the heart leap joyous as it, uh, as it own bright leap joyous as it own bright singing waves. I'm sorry, I got a little lost. Clearing the clouded brain, making the heart leap joyous as it own bright singing waves. Okay. Well, which choice best describes the function of the underlined portion in the text? So that was the prompt. I probably should have read that first. So here is the underlined portion. It was just ever repulsed, yet ever rushing on, filled with a life that will not know defeat. So these lines characterize the sea waves as relentless and enduring force. So that one wasn't too bad. There's a poem. You might see a short poem on the test. All right, now on to number 6. It's a paired passage. So we have two different authors, author one, author two. They are not the same people, although they are both writing about the same topic. I like to always read the prompt first. Based on the text, how would Barenfeld and colleagues, text 2, most likely respond to the conventional wisdom discussed in text 1? So that was this part. All right, I'm going to read both passages, and then we just have to come up with what author 2 would say about this part from author 1. Ecologists have long wondered how thousands of microscopic phytoplankton species can live together near ocean surfaces, competing for the same resources. According to conventional wisdom, one species should emerge after outcompeting the rest. So why do so many species remain? Ecologists' many efforts to explain this phenomenon still haven't uncovered a satisfactory explanation. So that was text 1. Here's text 2. Ecologist Michael Barenfeld and colleagues have connected phytoplankton's diversity to their microscopic size. Because these organisms are so tiny, they are spaced relatively far apart from each other in ocean water, and, moreover, experience that water as a relatively dense substance. This, in turn, makes it hard for them to move around and interact with one another. Therefore, says Barenfeld's team, direct competition among phytoplankton probably happens much less than previously thought. All right, so based on the two passages, what would our second group, what would Barenfeld and colleagues say about the conventional wisdom from the first author? Well, we have some answer choices. I'm just going to go through some of them. Let's see if we can roll out some. Answer choice B says, by asserting that it fails to recognize that routine replenishment of ocean nutrients prevents competition between phytoplankton species. Neither passage mentions this. I'm going to cross it off. By suggesting that their own findings help clarify how phytoplankton species are able to compete with larger organisms. Neither passage explains the idea that phytoplankton compete with larger organisms. D says by recommending that more ecologists focus their research on how competition among phytoplankton species is increased with water density. We know that the water density makes competition less, right? It says water is a relatively dense substance. This in turn makes it hard for them to move around and interact with one another. So that would reduce competition, not increase it. The right answer was A, by arguing that it's based on a misconception about phytoplankton species competing with one another. All right, so that one actually wasn't too bad. Let's look at 7. This is on page 937. All right. Looks like it's another science passage. All right. I like to read the prompt first. According to the text, why was Wang and his team's discovery of the Pteropterus zhuchenensis fossil significant? All right, so I'm going to read this passage and let's see if we can come up with why the discovery of this fossil is significant. For many years, the only existing fossil evidence of Mixopterid eurypterids, an extinct family of large aquatic arthropods known as sea scorpions and related to modern arachnids and horseshoe crabs, came from 4 species living on the paleocontinent of Laurussia. So that's, yeah, the continents have moved around, right? So this is one of them. In a discovery that expands our understanding of the geographical distribution of Mixopterids, paleontologist Bo Wang and others have identified fossilized remains of a new Mixopterid species, Pteropterus zhuchenensis, that lived over 400 million years ago on the paleocontinent of Gondwana. So the key to getting this question correct is just to realize that we were talking about only the paleocontinent of Laurussia, and now we are also talking about finding Mixopterids on the paleocontinent of Gondwana. That's a different paleocontinent. Okay, so now we should have the right answer. D, the fossil constitutes the first evidence found by scientists that Mixopterids existed outside the paleocontinent of Laurussia. Yep, because the only existing fossils initially were in Laurussia. So that one wasn't too bad. I'm going to keep moving on to number 8. I like to read the prompt first. Which statement about the Difracismo in Coatli in Ocelotl, that's an animal, ocelot, is most strongly supported by the text? All right, so that's what we're looking for. I'm going to read this passage, and then we have to come up with the right answer. All right, poetry in classical Nahuatl, the language of the Aztec Empire, relies on difracismo or a parallel noun construction that conventionally operates as a single metaphor. So, you know you've done a lot of SAT questions when you realize this isn't even the first question about Nahuatl, the language of the Aztec Empire. We did one of these like a couple weeks ago, I think, that was about the same language. Oh, okay. Anyway, for example, the common difracismo in this expression, coatli in ocelotl, literally the eagle, the jaguar. Yeah, see, I knew that was an animal. Signifies warrior. The devices function in both formal, providing structure to lines of verse. Sorry, the device's function is both formal, providing structure to lines of verse, and ritual. Semantic relations among the two nouns and the concept they signify can be tenuous, as in the previous example, such that difrasismos are often only intelligible according to the conceptual associations observed in Aztec ceremonial culture. Interesting. Okay, so here are our answer choices. Let's see if we can eliminate some of these answer choices. Answer choice B says its unintelligibility may cause its formal function within a line of verse to go unnoticed by present day readers. I don't think that we would say it's unintelligible necessarily. Its apparent obscurity can be resolved when considered in the proper cultural context. That's C. D says its frequency in classical Nahuatl poetry confirms its intelligibility to the Aztec audience. That doesn't make much sense to me. I think we have it narrowed down to A or C. A says its metaphorical significance derives from the semantic equivalence of the two nouns constituting the diffrasismo. Does that make more sense, or does this make more sense? Its apparent obscurity can be resolved when considered in the proper cultural context. Let me read the second half of this last sentence just one more time. I think that this really indicates which answer it is. Semantic relations among the two nouns and the concepts they signify can be tenuous, can be unclear. As in the previous example, such the diffrasismos are often only intelligible according to the conceptual associations observed in Aztec ceremonial culture. So there's culture in the passage, and then there's culture in the right answer, C. Anyone put C for this one? It's a tricky one. Julia got it. They're getting harder. All right, I'm gonna keep. All right, I think we're on to maybe we're on to the next batch of these. We're just doing these in batches, Jacob. Okay, so now we are at the infographics. So here we have a line graph. There are three types of infographic on the SAT. There are line graphs, bar graphs, and charts, tables. So here we have a line graph. I'm gonna let you do 9 is an infographic question, 10 is not, but 11 is. I think let's just do 9 to 11 and get rid of all the infographic ones just in one go. And then we will do another batch after that. So let's just try 9 through 11 and take a few minutes. Take about 5 minutes. These ones you have to um, refer to the data, so these take a little bit longer maybe. So we'll take about 5 minutes for these ones, and then we will go over them. All right, it's been about 5 minutes, so we'll go over these three. All right, 9. All right, we have our first graph. All right, so I like to always read the title of the graph. I like to read the x-axis, read the y-axis, read the key. So it says ratio of manganese to calcium in samples from the Alboran Sea and Mauritanian coast. And then the x-axis is approximate years before present in thousands. Okay. So here are we. We're at 0,000 years before now. We're at now. And then this is older, going that way. Okay. And then we have our key. The triangle is Alboran Sea. The square is Mauritanian coast. And then our y-axis is just manganese to calcium ratio in micromoles per mole. Okay. The population of the coral Lophelia pertusa declined significantly around 9,000 years ago in the Alboran Sea. So I'm going to make a note of that. In around 11,000 years ago near the Mauritanian coast. Make a note of that. Using the ratio of manganese to calcium, which inversely correlates with ocean oxygenation levels, marine scientist Rodrigo da Costa Portillo Ramos and colleagues evaluated whether oxygenation played a role in the declines of L. pertusa. The researchers concluded that oxygenation may have been important in the Alboran Sea, the triangle, but not near the Mauritanian coast. Since, and then we're asked to fill in the blank. So the Mauritanian coast was our square, the Alboran Sea is the triangle. Just kind of trying to keep myself on track here. Okay. Okay, so we have thousands of years before now. Okay, so just looking at our graph, looking like from around 10,000 years ago to around 8,000 years ago, just looking at in this interval, let me get a different color. Let's try red. Is the manganese to calcium ratio increasing or decreasing on that interval? I'm just asking you guys. What do you think? Is it increasing, decreasing compared to now? Like we're here. Who says increasing? Nobody. Wait, let me see what Jacob thinks. No, Jacob walked away. It is increasing. It's going up, right? So that inversely correlates to oxygen levels. So what that's just the Alboran Sea. What about the Mauritanian coast? We kind of just are like this. So the manganese to calcium ratio seems to not be changing at all. And that's the second half of our answer. So what we could say, based on the graph, the researchers concluded that oxygenation may have been important in the Alboran Sea, but not near the Mauritanian coast, since B. L. pertusa declined in the Alboran Sea during a period of substantial local decline in oxygen. So higher manganese to calcium ratio means lower O2. They are inversely correlated. But L. pertusa declined near the Mauritanian coast during a period of little local change in oxygenation. So this line, this horizontal line here, shows that O2 levels have not changed throughout all of these thousands of years. So that's why this one was B. They're getting hard. That one was hard. Who thought that one was hard? Anybody? Yeah, that was tricky. The hardest part, I think, is this. If you miss that, you would get the wrong answer. So I don't know. That was a tricky one. We'll move on to the next one. This one's easier. All right, let's see what's going on with number 10. Psychologists Dasher Keltner and Jonathan Haidt have argued that experiencing awe, a sensation of reverence and wonder typically brought on by perceiving something grand or powerful, can enable us to feel more connected to others and thereby inspire us to act more altruistically. Altruism, it means you act selflessly. You're helping other people or something like that. Keltner, along with Paul K. Pia Dietz, and colleagues, claims to have found evidence for this effect in a recent study where participants were asked to either gaze up at exceptionally tall trees in a nearby grove, reported to be a universally awe-inspiring experience, or stare at the exterior of a nearby nondescript building. After 1 minute, an experimenter deliberately spilled a box of pens nearby. All right, so that was the experiment. Which finding from the researchers' study, if true, would most strongly support their claim? So let's see if we can eliminate some of these answers. I'm going to consider answer choice B. Participants who have helped the experimenter pick up the pens used a greater number of positive words to describe the trees and the building. How would they have seen both? They either look at the trees or they look at the building. In a post-experiment survey, then did participants who did not help the experimenter. That makes no sense. Here's C. Participants who did not help the experimenter pick up the pens were significantly more likely, okay, so they did not help the experimenter. They were significantly more likely to report having experienced a feeling of awe, regardless of whether they looked at the building or the trees. Answer choice C makes no sense to me. Here's D. Participants who had been looking at the building were significantly more likely to notice that the experimenter had dropped the pens than were participants who were looking at the awe-inspiring thing. So that doesn't work. Hopefully it's A. Participants who had been looking at the trees, the awe-inspiring thing, helped the experimenter pick up significantly more pens than did participants who had been looking at the building. That makes perfect sense. So that would show altruism for the tree people, but not the building people. All right, on to the next one. All right, we have another graph here. This graph isn't nearly as bad as the last graph, so I apologize for that other one if you missed it. This one should be much easier. Power conversion efficiency of lowest and highest performing spin-coated and spray-coated electron transport layers. We have lowest performing, we have both types there. We have highest performing, both types there. Spray coating is the light gray. Spin coating is the black or the dark gray. The y-axis is power conversion efficiency in a percent. All right, I'm going to read this. Oh, it's about solar. Perovskite solar cells convert light into electricity more efficiently than earlier kinds of solar cells. And manufacturing advances have recently made them commercially attractive. One limitation of the cells, however, has to do with their electron transport layer, ETL, through which absorbed electrons must pass. Often the ETL is applied through a process called spin coating. But such ETLs are fairly inefficient at converting input power to output power. All right, so I'm going to label that inefficient. All right, so that's inefficient. Okay, and then let's see what's the other kind. Andre Taylor and colleagues tested a novel spray. That just means a new spray. Coating method for applying the ETL. The team produced ETLs of various thicknesses and concluded that spray coating holds promise for improving the power conversion efficiency of ETLs in perovskite solar cells. I'm going to label this efficient. All right, so we have the efficient kind and we have the inefficient kind. I'm spelling efficient wrong. Sorry. Okay, here we go. So I'm just going to consider some of these. Here are our answer choices. Which choice describes data from the graph that support Taylor and Colley's conclusion? So we are looking to try to show that the spin coating is inefficient and the spray coating is efficient. Here's A. Both the ETL applied through spin coating and the ETL applied through spray coating showed a power conversion efficiency greater than 10% at their lowest performing thickness. So I'm going to lowest performing. Here's lowest performing. So both the ETL applied through spin coating and the ETL applied through spray coating showed a power conversion efficiency greater than 10% at their lowest performing. So that is true, but does it support the researcher's conclusion? I'm going to label it true for now, but there may be a better answer. B says the lowest performing ETL applied through spray coating. I'm going to label this. Lowest performing ETL with the spray coating is here. Had a higher power conversion efficiency than the highest performing ETL applied through spin coating. Is that bar higher than this bar? Yes. And that would support the researcher's conclusion. I'm saying it's B, but let's see what C has to say. C says the highest performing ETL applied through spray coating showed a power conversion efficiency of approximately 13%. That's not even true. While the highest performing ETL applied through spin coating showed a power conversion efficiency of approximately 11%, that's also not true. That's just, the graph doesn't even show that. D says there was a substantial difference in power conversion efficiency between the lowest and highest performing ETLs applied through spray coating. The one that would support the research conclusion is B. Yeah. Okay. So yeah, this bar is highest than even the lowest performing spray coating is higher than even the highest performing spin coating. That one's not bad at all, really. Okay. All right, so we finished up all of the infographics. So I think I'm going to find another batch of these to try. I want to do, let's do all the way up to the grammar. We'll do everything up to the standard English conventions. So let's do 12, 13, and 14. Let's just try 12 through 14. We'll try to do these in about 3 minutes. Let's keep it real, like the real test. So in about 3 minutes, we will go over 12 through 14. All right, it's been about 3 minutes, so let's go over these ones. Let's try 12. Okay. I like to read the prompt first. Which finding from Washington and Mullainathan's study, if true, would most directly weaken the claim made by people who favor the traditional view of voter behavior? What's the traditional view of voter behavior? It's this. Political scientists who favor the traditional view of voter behavior claim that voting in an election does not change a voter's attitude toward the candidates in that election. Okay, so we're trying to disprove that idea, that traditional view of voting behavior. We're trying to weaken the claim of that type of people, that type of group, sorry. All right, I'm going to read this one and yeah, let's see if which statement would weaken that claim. Political scientists who favor the traditional view of voter behavior claim that voting in an election does not change a voter's attitude toward the candidates in that election. Focusing on each U.S. presidential election from 1976 to 1996, Abanya Washington and Sendil Mullainathan tested this claim by distinguishing between subjects who had just become old enough to vote, around half of whom actually voted, and otherwise similar subjects who were slightly too young to vote and thus none of whom voted. Washington and Mullainathan compared the attitudes of the groups of subjects toward the winning candidate 2 years after each election. Okay, and now we have our answer choices. So we're trying to weaken the claim made by people who favor the traditional view of voter behavior. All right. I think this is C. Let me read C. Subjects who voted in a given election held significantly more polarized attitudes toward the winning candidate 2 years later than did subjects who were not old enough to vote in that election. So polarized can mean either pole, right? Like a magnet. So subjects who voted in a given election held significantly more polarized attitudes toward the winning candidate. So they either really liked the winning candidate or they really disliked the winning candidate. And they voted 2 years later than did subjects who were not old enough to vote in that election. So answer choice C would weaken the claim that the traditional view of voting behavior, this claim that voting in an election does not change a voter's attitude toward the candidates in that election. So this would disprove the traditional view. C. Maybe I'll go through some wrong answers. A subject's attitudes toward the winning candidate 2 years after a given election were strongly predicted by the subject's general political orientation, regardless of whether subjects were old enough to vote or not. So that wouldn't tell us what we want to know, right? Because that disregards whether or not they voted. B, subjects who were not old enough to vote in a given election held significantly more positive attitudes toward the winning candidates 2 years later than they held at the time of the election. So they were not old enough to vote. So that wouldn't work either for what we're trying to do, what we're trying to disprove. 2 years after a given election, subjects who voted and subjects who were not old enough to vote were significantly more likely to express a negative attitude than a positive attitude toward the winning candidate in that election. That wouldn't really show us much, but C would. Subjects who voted in a given election held significantly more polarized attitudes. If they held stronger attitudes, whether like or dislike toward the winning candidate, that would show that voting in that election had an effect. All right, on to number 13. All right, here's one about monkeys. Read this one. Which choice most logically completes the text? Among social animals that care for their young, such as chickens, macaque monkeys, and humans, newborns appear to show an innate attraction to faces and face-like stimuli. Elisabetta Versace and her colleagues used an image of three black dots arranged in the shape of eyes and a nose or mouth. Looks like this. To test whether this trait also occurs in testudo tortoises, which live alone and do not engage in parental care. They found that tortoise hatchlings showed a significant preference for the image. Okay, interesting. So these tortoises do not engage in parental care, yet they found the tortoise hatchlings showed a significant preference for the image. Going to go through some answers. Let's consider A. Would this does this belong in the blank? They found the tortoise hatchlings showed a significant preference for the image, suggesting that face-like stimuli are likely perceived as harmless by newborns of social species that practice parental care, but as threatening by newborns of solitary species without parental care? Put a question mark here. The the tortoises liked the image. It doesn't make much sense to me. I'm going to consider B. Researchers should not assume that an innate attraction to face-like stimuli is necessarily an adaptation related to social interaction or parental care. That makes sense. So if they like this image, if they like the face I drew, um, researchers should not assume that an innate attraction to face-like stimuli is necessarily an adaptation related to social interaction because these tortoises are not raised by parents, right? Let's see. C says researchers can assume that the attraction to face-like stimuli that is seen in social species that practice parental care is learned rather than innate. So the tortoises don't lead me to believe that, and there's no mention of this being a learned trait in either the parental cared for ones or the ones who don't have parental care. Newly hatched testudo tortoises show a stronger preference for face-like stimuli than adult testudo tortoises do. That wouldn't really show us anything. Okay, I am moving on to, I think we're finally in the grammar. Or no, I have to do 14 first? Okay. The monkey one. And I don't want to waste a lot of time on this monkey one. The correct answer was A. So just grade your paper. I want to get to the grammar. Like I want to at least do some grammar till we will be done on time tonight. So let's just try to do all of the grammar. There are seven of them. Yeah, let's just do 15 through 21. I think this will leave us plenty of time to try all the grammar. So give these ones a shot. I'm going to try to go over these in about 10 minutes. Okay, I'm going to start going over these just because we're almost out of time. So hopefully you had time to try all of these grammar questions. If you didn't get to the last one, that's fine. But let's just go over some of these. All right. All right. So the first one. Okay, so is there a strategy we can use to test for punctuation? I'm looking at the answer choices. That's the only difference between all of the answer choices. We have a strategy. What is it called? Does anyone remember? It's just something I made up. It's got a dumb name. I probably need to make a more PC name for this strategy. But it literally introduces a stutter into your sentence if it's unnecessary punctuation. So it works. I'm going to read this both ways. I'm going to read it with a pause after gingerbread. I'm going to read it with no pause after gingerbread. In crafting her fantasy fiction, Nigerian-born British author Helen Oyeyemi has drawn inspiration from the classic 19th century fairy tales of the Brothers Grimm. Her 2014 novel Boy, Snow, Bird, for instance, is a complex retelling of the story of Snow White, while her 2019 novel Gingerbread offers a delicious twist on the classic tale of Hansel and Gretel. So that's an option. Or would every native speaker say this? Her 2014 novel Boy Snow Bird, for instance, is a complex retelling of the story of Snow White, while her 2019 novel Gingerbread offers a delicious twist on the classic tale of Hansel and Gretel. No one would pause there. Yeah, there's no punctuation. Punctuation, there are pauses in language. It's all the punctuation that belongs there. But we can't just, and I can't just, if I threw random commas in this passage and read them as pauses, you would hear unintentional, unintended pauses. So the strategy works. Okay, looking at the answer choices for 16, I am noticing that the only difference between these answer choices is punctuation. Do we have a strategy? Yes, the same strategy. All right, here we go. When external forces are applied to common glass made from silicates, energy builds up around minuscule defects in the material, resulting in fractures. I'm going to read it both ways. Recently, engineer Erika Frankberg of Tampere University in Finland used the chemical compound aluminum oxide to make a glassy solid that can withstand higher strain than silicate glass can before fracturing. Okay, or would we say this? Recently, engineer Erika Frankberg of Tampere University in Finland used the chemical compound aluminum oxide to make a glassy solid that can withstand higher strain. No pauses at all. Answer choice C had two stutters. So just read the pauses in there. You would never pause um, after either of those words. So that one was D. It works. It's a real thing. I don't know. I think it works. Let's try 17. Here they are testing us on run-ons. In 1943, in the midst of World War II, mathematics professor Grace Hopper was recruited by the U.S. military to help the war effort by solving complex equations. Hopper's subsequent career would involve much more than just equations, though. As a pioneering computer programmer, Hopper would help usher in the digital age. So my first question is, does this adverb though, does it modify the previous clause or the next clause? What do you think? Who thinks previous? I agree. So C is out. And now we have our run-ons. They always give us the regular run-on. They always give us the comma splice run-on. So if we use the colon after though, there's no run-on at all. No more problem. All right, 17, 18. Okay, so here's one about subject-verb agreement. Could also be about tense. So I indicated the various different tenses, but also whether the subject is singular or plural. Increased gender diversity is revitalizing the field of economics, according to Harvard's Claudia Golden. The trailblazing accomplishments of Golden, winner of the 2023 Nobel Prize in Economics for her work on women in the labor force, blanks to the value of scholars of diverse backgrounds in spurring research into previously unexplored but vitally important topics. Okay, so what was our subject for that sentence? It's this. Is accomplishments singular or plural? It's plural. All of the other answer choices are singular and incorrect. The trailblazing accomplishments attest to the value of scholars of diverse backgrounds. So plural subjects take plural verb forms, singular subjects take singular verb forms. All right, number 19. This is the one that everyone thought was the most difficult on Sunday and the one that I think everybody missed. So we'll see how you guys did. Recent pollen analysis of the Aran Islands have led some researchers to propose that the now treeless islands were once wooded. This hypothesis blank that certain trees, such as P. sylvestris, survived without interruption or human intervention throughout the Holocene cannot stand, researchers Michael O'Connell and Karen Molloy counter, unless other explanations can be ruled out. So we have three grammatically incorrect answer choices and one grammatically correct answer choice. Suggesting is a present participle, and we can use it to form a participial phrase that modifies a main clause. And that is the right answer for number 19. Everyone on Sunday thought it was C. Did they get you guys? Yeah, some of you. Yeah, I'm seeing some.
I chose C at first, and then I had to
I
cross it
think
out and go back to A on my second reading.
I Mrs. Hessler picked C, but like on Sunday I was talking about this to someone, and they were like, I just didn't read far enough. If I had read all the way to that period, I would have realized it has to be A. But I got like a little bored like halfway through the beginning of the sentence, and I picked C, so don't get bored on Saturday if you're taking the test. This next one's about tense. We're just gonna do a couple more and we'll be done. So yeah, sorry about that last one. All right. I've indicated all the tenses we have here. All right. Atoms in a synchrotron, a type of circular particle accelerator, travel faster and faster until they blank a desired energy level, at which point they are diverted to collide with a target, smashing the atoms. So we need the same tense as this verb, and we need the same tense as this verb. Those are all present tense, which was the correct answer B. So atoms in a synchrotron, a type of circular particle accelerator, travel faster and faster until they reach a desired energy level, at which point they are diverted to collide with a target, smashing the atoms. So we just can't switch into a strange tense. That doesn't make any sense. We're in present. Everything's in present. Okay. And then this is the last one we're going to do. They are testing us on unlike versus like comparisons. So, and this is just a type of question that they put on the SAT, but basically, I can only compare like things with other like things. So I can compare, I don't know, the volume of this glass to the volume of this glass. I have props for some reason. I can compare the length of this pencil to the length of this pencil. I cannot compare the length of this pencil to the entirety of this pencil. I can't compare the length of this pencil to, I don't know, the eraser of this pencil. Let me give you another example. If I have the heights of two people, I cannot compare the height of Jack to the entirety of Alex, to Alex's weight, Alex's size, Alex's eye color. You can only compare the one aspect of something with the similar aspect in the other thing. So here's the question. Compared to that of alumina glass. Hopefully you saw that. That's important. Compared to that of alumina glass, blank silica glass atoms are so far apart that they are unable to reform bonds after being separated. Which choice completes the text so that it conforms to the conventions of standard English? So I cannot compare the glass atoms of alumina glass to the entirety of silica glass. Just can't do it. I cannot compare the atoms of alumina glass to the entirety of silica glass. I cannot compare the atoms of alumina glass to a significant disadvantage of silica glass. That's weird. But I can compare the atoms of alumina glass to silica glass's atomic arrangement. So compared to that of alumina glass, silica glass's atomic arrangement is more dispersed. That's what I was comparing. I was comparing their atomic arrangement, and you would only notice that if you saw these words, that of alumina glass. So that's why this one is D. Hopefully you realize I can only compare like with like. Yeah, and we're done on time. So, any questions? You guys are the best group we've ever had virtually. I just have to say that it's just a true statement. So, thanks for being so awesome. Good luck on your tests. Please tell us how you do. Just shoot Mrs. Hessler a quick email. It takes no time at all. You'll know in 2 weeks. They'll have your scores in 2 weeks. You can take the test more than once, so don't panic. You can take June. There are more tests coming up. There's May. So yeah, any questions before I sign us off? This is our final SAT class. You guys are ready. So hopefully tonight was helpful. Yeah, good luck. Jacob's crossing all his fingers. Yes, no, you guys are gonna crush this test. So have a great evening and good luck.
Thank
Bye.
you very much.
Yeah, thank you. Bye bye. Bye.